Unmanned aerial vehicles are typically associated with military applications. However, increased availability of the technology has recently led to more extended use of UAVs in other fields. One possible application is search and rescue. With iSaR-UAV, we have proven this is a viable concept through designing and building an aircraft which integrates a specialist microcontroller, infrared cameras, and prefabricated airframe.
The airframe boasts a stable design with a large wing area coupled with spacious internal compartments to allow the storage of all the necessary components.
The airborne system is controlled by a Pixhawk microcontroller, which interfaces directly with the actuators, the infrared camera module, as well as transmitting data wirelessly directly back to our ground control system.
As a proof of concept, the infrared camera from a Wii remote has been adapted to detect an infrared beacon from the air.
The ground control allows real-time monitoring of the in-flight parameters, as well as exporting the points of interest over here to Google Earth.
Testing of the motor was performed by connecting the battery, speed controller, motor and propeller together, and was controlled using the RC controller interface to the Pixhawk. This allowed for the determination of the thrust produced by the motor and propeller, as well as the calibration of the voltage and current measurements to be used during flight.
The Wii camera is driven by an Arduino Uno, which can be connected up to a customised application to visualise where the detected hotspot is in relation to the camera.
Pre-flight ground tests, including taxiing the UAV, were performed in order to confirm the correct operation of the servos and motor with respect to their given input commands.
To test the autopilot hardware and the associated circuitry, hardware-in-the-loop testing was conducted to show how the controls would respond to various inputs. This also allows pilots to practice flying in a risk-free environment.
The final stage of testing was flying the plane itself and tuning the control parameters to allow for autonomous flight. When the plane detected an infrared hotspot, it logged the GPS coordinates pinpointing the location on Google Earth.
This project is a good example of integrated system design, utilising different engineering disciplines such as aerodynamics, software and control.
iSaR-UAV shows how these technologies can be applied to create an intelligent unmanned aerial vehicle, which can aid in the completion of successful search and rescue missions.